A very good evening to all. Now it's audio video clear? Yes friends, audio video clear? Yes, audio video clear है? Audio video clear? Yes. Today we will start theory of computation. Today we will start theory of computation. So first of all, we'll see what is the weightage of this subject. Yes, please confirm my audio video is clear. Yes dear friends, audio video clear है? Now, so what is the weightage of this subject? The weightage of this subject is 7 to 10 marks. 7 to 10 marks. And it is 100% scoring subject. It is 100% scoring subject. So first of all, we'll see what are the syllabus, what are the content of this subject. So in this subject, first we will see finite automata. Second topic is push down automata. Third topic is Turing machine. And fourth one is decidability or undecidability. And undecidability. Here we include grammars also. Grammar, we will discuss grammar after in between the finite automata and PDA. Clear? Yes, Sneha. Now audio video clear hai? So the weightage of each topic is, the weightage of this topic is 70%. And the weightage of this topic is 15%. And the weightage of these two topics is also 15%. Definitely you will get 2 to 3 marks question from, or we can say 20% of weightage of this topic and 10% weightage of this topic. You will get definitely 2 to 3 marks question from Turing machine and decidability. Decidability is also cover some part of PD and finite automata. Clear? Okay. Now, in first lecture, we'll see what is the theory of computation and what are the component that involve in this subjects. So today is our introduction lecture. Today we will see whole scenario of TOC, theory of computation. So see my dear friends, we have 4 circles. We have these 4 circles. So what do you mean by these 4 circles? What do you mean by these 4 circles? Suppose I'm here, and this is Bhopal, and this one is India. If I'm telling you I'm from Bhopal, so by default its meaning is that I'm from Indian. But if I tell you I'm Indian, so it doesn't mean I'm belong from Bhopal. Clear? So if I'm here, then I'm also in this circle, and in this circle. Clear? So what do you mean by this? This is the type 3 circle. Type 3. Don't worry what is type 3, what is type 2, what is type 1, what is type 0. We'll discuss each and everything in detail. It's just a introduction. Type 3, and this circle is type 2. This circle is type 1, and this circle is type 0. Type 0. Now, see. If we are talking about the type 3 circle, this circle is known as regular grammar. Regular grammar. What is what is regular grammar? We'll see later. Regular grammar. The language generated by this grammar is regular language. The recognizing machine, for this language we have finite automata. Finite automata classified into 2 categories: deterministic finite automata and non-deterministic finite automata. Forget about this. What is NFA? What is DFA? What is a regular grammar? What is a regular language? Today we will see only the whole scenario of TOC. What we will study in further lectures. Okay? Clear? Clear? Please share the session as much as possible and like the session first. So those who are present in the live class, please share the session as much as possible, and first you like the session. Now, the power of NFA and NDFA and DFA are same. What is the power? Forget about the power. Power means whatever we done by DFA, this also be can done by NDFA. This is the power. Okay? Okay? Okay, wait. I think some problem in the camera. Isn't it is visible? It is visible. Isn't it is visible? Isneha, it is visible, clearly visible. Is there, it is clearly visible, or you have some problem? Please let me know. This is visible or not? Okay. Okay. I think see, it is clearly visible. No. Wait. Now it's visible. Now, okay, it's fine. See, so what is the grammar corresponding to the type 3? Regular grammar, and the language generated by the regular grammar is regular languages, and recognizable machine is finite automata. Finite automata classified into two categories. First one is DFA and second one is NDFA. The power of NFA and DFA both are same. What do you mean by the power? Whatever be done by the DFA, this also be done by the NFA. Now, second, type 2. Type 2. The type 2 is context-free grammar. Context-free grammar. The languages generated by the context-free grammar is CFL. Context-free language. The machine for this language, recognizable machine, is PDA, push down automata. Push down automata. Push down automata again classified into two categories: DPDA, deterministic PDA, and non-deterministic PDA. NPDA, non-deterministic PDA. NPDA. The power of the NPDA is greater than the power of the DPDA. It means NPDA is more powerful than the DPDA. NPDA is more powerful than DPDA. Is it clear? Is it clear? Okay. Now, type 1. Type 1 known as context sensitive grammar. The language generated by is CSL, context sensitive language. Context sensitive language. And the recognizable machine is LBA. Recognizable machine is LBA. Linear bounded automata. Linear bounded automata. The classification of LBA we don't know because research is going on LBA, so there is no, or we can say there is no, there is not of more information is available on LBA. Now, type 0. Type 0 is unrestricted grammar. Unrestricted grammar. The language generated by the unrestricted grammar is recursively enumerable. Recursively enumerable. Recursively enumerable. The recognizable machine for this, Turing machine. Turing machine. Turing machine. Here we define one classification of Turing machine, deterministic Turing machine and non-deterministic Turing machine. But it is not actually exist. Please listen carefully. Actually, non-deterministic Turing machine is a variation of deterministic Turing machine. But sake of easiness, I am right here. Turing machine divided into two parts, deterministic Turing machine and non-deterministic Turing machine. But actually, non-deterministic Turing machine is a modification of standard Turing machine. The power of deterministic Turing machine and deterministic Turing machine both are same. Both are same. Now, if we are talking about the power of finite automata, PDA, LBA and Turing machine, then finite automata is less powerful. PDA is more powerful than finite automata. LBA is more powerful than PDA. And Turing machine is highest powerful as compared to the other abstract machine, other machines. So this is whole TOC. We'll discuss one by one, each chapter one by one. First we discuss finite automata, then PDA, then type 0 and type 1, both are combined, we will study. So this is the complete diagram of theory of computation that will be discussed in further lectures. Okay, so please note down this diagram. If you have any query regarding this diagram, you can ask me. It is clearly visible? Yes, Sneha, it is visible. Yes, my dear, it is visible. This diagram is visible to you. Please confirm me. Okay. Okay. Have you noted this? Have you noted this? So these are the basically chapter 1, then chapter 2, chapter 3 and 4. Okay. See some questions. See some questions. Question 1. Which of the following are correct? Which of the following are correct? Which of the following are correct? Now, option 1. Option first. Sandeepan, any problem? Sandeepan, any problem? First one is regular and CFL. Regular and CFL. Second one is regular but not CFL. Regular but not CFL. third one is CSL and CFL. CSL and CFL. Fourth, none of the above. Please find the answer of this question. You can find easily. Please look at diagram carefully. After that you can answer easily. Sir, ये TOC class right side can't visible. What is the problem? Yeah, wait. Here is everything is okay. I think. Wait, yaar, I will check. What is the problem? Manoj, TOC is started in the global channel. That's why फिर से चल रही है. Now Sandeepan, it's okay. Clear है बेटा ये? This one is clear. 2. The answer of this question is 2. It's given by the Sneha Jadon. Now check the first option. What is the first option? Regular and CFL. Now check here. If language is regular, then it is also CFL. If language is regular, then it is also CFL. So this one is true. Now second option is regular but not CFL. I am from Bhopal but I am not Indian. Regular but not CFL. This is not possible. Now what is the third option? CSL and CFL. This is false. If language is CFL, if language is here, then it is also here. It may or may not be. That's why this one is also false. So answer of this question is A. Answer of this question is A. Wait, मैं टेक्निकल टीम को फोन करके एक बार सही कराता हूँ उसको. This question is clear to all? This question is clear to all? This question is clear to all? Yes? This question is clear to all? Sandeepan, Manoj, Sneha, this question is clear to all? Yes, This question is clear to all? Okay, okay. Now come to the next question. Come to the next question. Come to the next question. Which of the following is not possible? Which of the following is not possible? Which of the following is not possible? My dear friends, still TOC not started. It just overview. It just a overview. Don't worry. So don't be a panic. It just overview. Option 1. Option 1. For every NFA we can construct, for every NFA we can construct equivalent DFA. For every NPDA we can construct equivalent PDA. Sorry, we can construct equivalent DPDA, deterministic PDA. Now, option third. For every non-deterministic Turing machine, we can construct equivalent deterministic Turing machine. None of the above. None. So what is the answer of this question? What is the answer of this question? Please tell me what is the answer of this question? Yes, Sandeepan, Manoj, Sneha. What is the answer of this question? Two. Answer is 2. For every NPDA, we cannot construct equivalent DPDA. Why? See the diagram. Please remember this diagram carefully. Why not? See this diagram carefully. The power of the NPDA is more as compared to the DPDA. So we cannot convert every NPDA into DPDA. But every NFA is DFA. Every deterministic Turing machine is non-deterministic Turing machine. That's why answer is 2. Clear? Clear, my dear friends? This is clear to you? This question is clear to everyone? This question is clear to everyone? Tell me fast. This question is clear to everyone or not? Sandeepan, this question is clear to you? Okay. We'll see next question. See the next question. Let NF and NP, let NF and NP are class of languages, are class of languages, are class of languages accepted by NFA and NPDA respectively. DF and DP are class of languages, accepted by DFA and DPDA respectively. Then which of the following is true? Which of the following is it true? Option A, LF equal to DF, NF equal to DF and NP equal to DP. B, NF greater than DF, this one is DF, DF and NP equal to DP. C, NF equal to DF and NP less than DP. D, NF equal to DF and NP greater than DP. So which one of the following is true? Which one of the following is true? Which one of the following is true? Now everyone come on this lecture. We will start TOC fresh and we will definitely complete TOC in this batch. Okay. So what is the answer of this question? What is the answer of this question? Sneha, Sandeepan, Manoj. What is the answer of this question? Please tell me, anyone. What is the answer of this question? So, see, what is the NF? NF is the some language. NF is the some language that is accepted by NFA, non-deterministic finite automata. CP107 वो यहीं पूरा होगा, वो इसीलिए बंद हुआ क्योंकि आप लोग सुबह आ नहीं रहे थे बेटा, शाम को इसी में कंप्लीट करेंगे उसको. CP107. Okay, CP107. NFA is the language accepted by NFA. NP is the language accepted by NPDA. DF is the language accepted by DFA. DP is the language accepted by DPDA. As we know that CP107 इसी बैच में आना है आपको. ओके, inform others. We will cover everything in this batch. Okay. So what is the relationship between NF and DF? We know that the power of NFA and DFA is same. So NF equal to DF and the power of NPD is greater than DPD and NP greater than DP. So which option is true? CP107, is it clear? So which option is true? This option is true. Clear? CP107 clear? ये क्वेश्चन क्लियर है? दिस क्वेश्चन इज क्लियर? This question is clear? Now, okay, come to the TOC. So this is all about the overview of theory of computation, what we will study in this subject. Clear? So TOC, theory of computation. Theory of computation. Very good evening. Chaturnath, very good evening. Theory of computation. The name of this subject is different in different colleges. Some colleges, this subject called automata theory, formal languages and its study. So what is this? How machine perform computation? It will give the answer of this. How machine perform computation. Or we can say computational capability of machine. Capability of any machine. So it is a mathematical model. Please listen carefully. Happy evening, Aisha. So please listen carefully. It is a mathematical model, or we can say it is an imaginary model or abstract model by which you can find out the capability of any machine and limitation of any machine. Machine that can be anything. It's mechanical, computer, calculator, anything. So with the help of this mathematical model, we can calculate capability of that machine. Is it clear to you? Is it clear? Clear, my dear friends? The definition of theory of computation is clear. That's why the name of the subject is theory of computation. Please respond me. Okay, now we will start some introduction part. First is symbol. First is symbol. What is symbol? Can anyone tell me what is symbol? What is symbol? It can be a character. Symbol, it can be a character. It can be a character. It can be a character like small a, small b, z, capital A, capital B, z, 0, 1, 9, and many more, and many more. It can be a character. Smallest unit. Okay, very good. Smallest unit. Now, second one is alphabet. Atomic. Very good. Very good. Second one is alphabet. Alphabet. It is denoted by sigma. It is denoted by sigma. Alpha. What is alphabet? Alphabet is alphabet. It is denoted by sigma. So, can anyone tell me what is alphabet? What is alphabet? Please tell me what is alphabet. Aisha, Chaturnath, Sneha. Can anyone tell me what is alphabet? Set of symbols over sigma. Set of symbols over sigma. Any finite non-empty set of symbol. Yes. Have you ever seen a language which have infinite symbols? Or have you ever seen a language which does not have any alphabet? No, no, never, never, never. That's why the definition of alphabet is any, please listen carefully, any finite non-empty set of symbols. The term non-empty, finite non-empty is very important. Set of symbols. This term is very important. Finite non-empty. Finite non-empty is very important. For example, we have 0, 1. This is the set notation. A, B. This one is also an alphabet. Clear, my dear friends? Clear? This is clear? This part is clear? The definition of alphabet is clear? The definition of alphabet is clear? The definition of alphabet is clear? Yes? Aisha, Chaturnath, Sneha, is it clear? Okay. Okay. We'll move on next. Next one is string. String. So what is a string? Sir, will you teach complete here so that we can follow your blindly? Yes, Yadunath, we will complete TOC, complete subject in this batch. So you can follow blindly and you can share as much as possible with your friends. And it's my guarantee, you can get 100% TOC from my lectures. Have you ever seen my computer network videos or DBMS video? Sequence of finite symbols called string. Very good. Isneha complete. It's my promise to you. Complete hoga. Don't worry. Complete hoga. Don't worry. I will complete this subject. And I will complete 100% this subject. Okay? Yes, Codex. I have completed Codex DBMS in Codex batch. Okay, so what is a string? What is a string? Finite sequence of symbols. Finite sequence of symbols over the given alphabet, given sigma. So that Yadunath Singh, you can trust me blindly. You feel next level in TOC, you feel next level in theory of computation. Okay? For example, we have sigma 0, 1. Now, we have strings like 0, 1, 0, 0, 1, 1, 0, 1, 1, 0 and many more. Clear? Now, note. We have one string with length 0, known as, some books known as epsilon and some book known as lambda. Some books it is represented by epsilon and in some books it is represented by lambda. This is the string whose length is 0. Isa, this is very difficult question. I will cover as all the topics in this subject as soon as possible. Okay. In the month of June, we will complete this subject. Okay. In the month of June, we will complete this subject. So one string with length 0 known as epsilon or lambda. In some books it is represented by epsilon and some books it is represented by lambda. What is the epsilon? Epsilon is the null string, or we can say null string. Clear? Now, I think The definition of a string is clear. Definition of the string is clear. Definition of the string is clear. Definition of the string is clear. Now, length of the string. Length of the string. Fourth. Length of string. Please listen carefully. That is very important. Suppose we have alphabet A comma B. Now, what is sigma 0? The meaning of sigma की power 0 is length of the string, a string whose length is 0, or null string, or null string. What do you mean by the sigma की power 1? The meaning of the sigma की power is 1. Number of string whose length is 1. So we have only two strings A and B. Now what is sigma की power 2? Length of the string is 2. So how many strings of length 2 possible? AA, AB, BB, BA, BB. 4 strings are possible. Similarly, length 3 and length n. Length n. So if we talk about the number of strings of length 0, so 2 की power 0, two की power 1, length 2 mod of sigma 2 की power 2. Similarly, number of strings of length n, number of strings of length n, 2 की power n. Is this clear to you? Is this clear to you? Is this clear to you? How we find the number of strings? Number of strings of 0 length, 1 length, 2 length, n length. These are the number of strings. Number of strings. General. If we find number of strings of length n over the given alphabet, given sigma, it is equal to mod of sigma की power n. Mod of sigma की power n. Is this clear to you? Is this clear to you? Please listen carefully. Is this clear to you? Please tell me. The content of the class is totally depend on you. If the class is interactive, then content is very effective. If class is not interactive, then I am also lazy. So content is not so much effective. So a humble request to you, make the class as much as possible interactive. Clear? This is clear to you? Now, See the next substring. Substring. So what is the substring? What is substring? What is substring? What is substring? What is substring, my dear friends? What is substring? Easy gate tips. Why I'm stopped the class? So, dear, what is the substring? What? Okay. Okay. What is the difference between null string and what is the difference between null string and empty set? Empty set. See, this is very big difference between null string and empty set. Null string is not a empty language. It contains a string whose length is 0, but empty set is contain nothing. Empty set is denoted by 5 and the language of empty set is empty. Clear? 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 Collection of consecutive set of symbols. Any consecutive sequence of symbols, any consecutive sequence of symbols over the given alphabet, any consecutive sequence of symbols, over the given string, that is very good, over the given string. So see, for example, we have a string TOC. Then what are the substrings possible for that? Epsilon, T, O, C, TO, OC, TOC. These 7 substrings are possible. Clear? These are the 7 substrings are possible for given string TOC. Hello.
Hi sir, good evening sir.
Good evening.
Sir, Pankaj sir बोल
बस clear? Yadunath, any problem? We will continue this lecture tomorrow. Okay? We will continue this lecture tomorrow. Have you any doubt in today's session? Have you any doubt in today's session? Okay. Thank you so much. We will see tomorrow. Okay. So thank you so much. शुभ रात्रि, जय महाकाल, जय हिंद, जय मां भारती.